Okay, so Sammy, here is this B1 here. I'm making this real quick little video thing talking about end behavior. So y equals x to the fourth minus 8x cubed plus 22x squared minus 24x plus 9. Alright, so that's what we have. Okay, this is a fourth degree, so we know it's going to make a W or an M. Alright, there's my nice W shape. Okay, so I want to talk about end behavior. So end behavior is what's happening at the ends of the function. Okay, so that would be at these ends. You know, I can't see much right there and right there, but that's what we want to know, is what's happening at the end. So as x gets very, very large, or as x gets very, very small, all right, what's happening in that function? So I'm going to switch over here. All right, so we're going to take a look at this. There we go. Here's my x and y axis. All right, we'll do it this way. Okay, so I think it kind of looked like something like that, right? So this is increasing, this is increasing. So what you want to do on end behavior, and we talked a little bit about this last night, because there were some people that were kind of confused, and it's not so much that they were getting end behavior wrong, that they were writing it incorrectly. So what we want to do is use limits to describe it. Okay, so we're going to use this limit, okay, as x approaches infinity, so that's positive infinity. What's this doing? Well, it's a fourth degree. Okay, so they're all fourth degrees or even degrees, even if it's a parabola, right? They're going to open up or open down. And that's the only thing they're going to do. All right, odd numbers, degrees, they open up and down. All right, but even numbers for degrees are always going to open up or they're going to open down. So the limit of this function, so we'll call it f of x, is equal to positive infinity because it's increasing. All right, so now the limit as x approaches negative infinity of f of x is also going to be positive infinity because, again, it's both opening up. All right, open up, open up. That's how you write it. Now, if you're writing it or typing it, it's a little bit harder to get this kind of subscript. So what do you do? All right, so how do you communicate to me? So you just go like this. The limit, okay, as x, you can use a hyphen with a little greater than sign, okay, approaches infinity. So if you can't find infinity, whatever, some people can, some can't, INF. Okay, so as we approach infinity, parentheses, f of x, parentheses, is equal to INF. All right, that tells me that's infinity. The limit as x approaches negative infinity, so I put a little minus in front of it, of f of x is equal to INF. So that's how you can write it. All right, so that was most likely what the situation was. But end behavior, look, if you have a graph, right, and the graph looks like this, okay, so it's an odd degree, all right, then the limit as x approaches positive infinity of f of x, all right, is equal to positive infinity because it's going up. All right, the limit as x approaches negative infinity of f of x, that should be a negative there, is equal to negative infinity because it's going down. Okay, some instructors, but not many, would say increasing, decreasing. I have seen that, but really in a proper sense, and in some things we should be pretty proper, we're going to use these infinities, okay, and we're going to use limit notation. That's what's going to ask you to do on the test. As far as logarithms go, you know, the biggest thing on logs is a definition. So if we have a log, say base b of x is equal to y, then the definition of that says that means b to the y is equal to x. All right, and one of the things that we said was that the logs in an exponential are inverses of each other. So the domain and the range switch. So you see here where y is the output, now it becomes the input. So what does that mean? So if I go to the log, and let's just say base 10 of 10,000, okay, that's equal to 10 to the 1, 2, 3, 4, right? So then that means that 10 to the 4th is equal to 10,000. All right, that's what the definition of a logarithm says. And that's what's important when you are doing problems with logarithms, okay? So, like, let me see. I think there's some solving logs. Like, here's a solve. Okay, this is on your review. Okay, so we're solving number 3, for example. Log base 3 of x is equal to 5. So if we use a definition, the definition says I'm going to take the base. All right, there's my output, but that becomes my input. And I would just figure that out, whatever 3 to the 5th is. Well, I can use decimals for that, 3 to the 5th. Okay. Let's see. Then I have log base x. This is number 2. So again, I'm going to use a definition. So x to the 3rd equals 343. Oh, well, now what do? Well, I got to cube root it. Okay, cube root both sides. And then I would just get x equals whatever cube root of 343 is. I'm not sure off the top of my head. I think it's, is it 7? 7 times 49? Yeah, I think it's 7. Okay. So that's, I mean, that's really the important part on logarithms. You might be asking me about the properties of logarithms. Okay, which basically says this. That when you have 2 logs and you're going to add them, that means it's just a product as a single log. All right, if it's minus and you're dividing, if we have an n log a base a of b, say, that's equal to the log base a. The base is really not important here, b to the n. So that n pops up there. Okay. Yeah, I don't really, I mean, that's your stuff on logs. If you use a definition, though, that's pretty much the big thing. I don't really have, you know, you've probably looked at some Khan videos. He's usually pretty good for most stuff. Some things he's good, some things he's not, but I guess that's just like, it's like any different than I am. So, you know, you can go back and look at some of the lessons, too, that we did. Kind of long, but you might, I don't know, get some things. I'm trying to think of some quick stuff that you could look up real fast. But Khan's about the only thing that comes to mind. All right. So anyway, hopefully it helps. I don't know what else I can really do because, you know, you're pretty, it's pretty general when you talk about logs. You weren't too specific. So if you want to, let me know a bit more specifically and maybe I can help you out. But anyway, so that's that. And again, remember that one of the things to think about is this test is really more on polynomials and rationals. And there are some things on logs. I'm not going to say there isn't, but most of the focus is on rationals and polynomials. So anyway, good luck. See you tomorrow.